Good morning. Welcome to JS minus JS, which is just a fun way to say that we're going to be talking about targeting and transpilation. To start things off, my name is Adam. I work for an organization called CoVenture, and we are a organization with a few different arms. We've got direct lending, venture capital investment, and cryptocurrency. As part of our venture capital, we also do a lot of technical analysis and consulting work around helping companies figure out their product market fit, etc. We also do custom development and solution design for them, for founders that don't really have a technical co-founder, that kind of thing. And sometimes that means developing applications. And sometimes those applications need to be written very quickly in ways that we're all comfortable with, which means that we end up writing a lot of JavaScript, which is great because I love JavaScript. However, JavaScript has, of course, changed considerably over, just my career and, since it was originally written in, 10 days back in the 90s. Today, we're going to be talking about where JavaScript is right now and how awesome that is, how we got there. We're going to quickly, just to frame the conversation, talk about the difference between compilation and transpilation, kind of define those terms in the context of this conversation. We're going to talk about why are we even talking about transpilation? Why is it important? Where did transpilation really come from? Where have we been in the past few years? And where are we now? What is the current landscape around transpilation and targeting JavaScript applications look like? And where are we going? What's the future of JavaScript and the future of transpilation? So, first off, congrats everybody, we're number 1. According to GitHub, industry analysts, everyone, JavaScript is the most written in language. 20+% of all active users and pull requests on top of, I think it's actually 23% right now, are in JavaScript alone. You can see this on the actual Octoverse website. If you go over to RedMonk, which is a developer-centric industry analyst group, they have their language ratings as well. And no matter what way you slice it, JavaScript is the most, it's certainly the most ubiquitous language on the internet, but it's also the most popular language to write in. And that is really cool, especially with the prevalence of modern web frameworks, as we were just talking about things like React and Vue and Angular, server-side engines like Node, and React Native, and other abilities to write JavaScript for the mobile platform as well. The prevalence of JavaScript continues to grow, and its market share continues to increase. And as somebody who enjoys writing JavaScript, that makes me very happy because it means my skill set is more attractive. So quickly, how do we define compilation and therefore transpilation? For the sake of this conversation, and you could get into the nuances in a lot of different places, and it could be a much longer conversation, and I'm happy to have that tonight at the happy hour if you'd like. Today, we're going to define compilation as transforming source code from one language to another, specifically from a higher level of abstraction to a lower level of abstraction. An example of this would be taking C and converting it to bytecode. Everybody make sense? Everybody on board with that definition? Cool. So we will call transpilation a subset of compilation, specifically compilation between languages with similar levels of abstraction. You also will often see this referred to as targeting. In our context, this means we are taking applications written in any number of languages and transpiling that to JavaScript. So why the heck do we do this? Why not just write pure JavaScript? Wouldn't that make us cooler and more hardcore? Well, abstraction is our friend. It is easier to write things in ways that protect us. It allows for richer and more complex applications. When we write something that really requires strong typing, why would we fudge that with JavaScript, something that doesn't actually require it? And why don't we just conceive of our application in a way that can easily handle loose typing? I mean, you could do that. But if you're someone who is used to object-oriented programming, it would certainly be more appealing to write it in a way that you didn't have to do that. Developers write better when they write in what they're comfortable with. And developers can force the stack, regardless of the product. If you're curious about this or want to read more, there's a great book called The New Kingmakers by Stephen O'Grady. And he is actually also at RedMonk. It has a number of examples of product decisions, specifically application languages, that have shaped the landscape right now. If you're ever curious about how certain applications, for example, Hadoop ended up being written in Java, that's a great example, and I got a story to tell you. Finally, a bigger tent means more innovation. The more people who are interested in and attracted to writing, not necessarily purely in JavaScript, but in sometimes JavaScript adjacent, or in applications that will eventually target JavaScript, the better all of the JavaScript landscape becomes. Here are the current rankings that we were talking about earlier for language popularities. And this is up to date as of the beginning of this year. Again, JavaScript's number 1, Java, Python, PHP. There's been a little bit back and forth there. C#, C++. CSS is included here, and I think that's totally reasonable, especially if you consider the definition of language as something to be proficient with and that you can define. I personally am kind of terrible at CSS, but I'll write all the back-end stuff you want. It feels like an alien language sometimes, so I'm perfectly happy with this definition. An interesting thing, and we'll get to this a little bit later, is about at the top of the bottom third, TypeScript is sitting there as its own language, which is kind of awesome. And we'll get to that in a little bit. So where did we come from? When we talk about transpilation, there are 3 that come to mind almost immediately. And they've been in the play space for a little bit already. CoffeeScript, TypeScript, and Babel. CoffeeScript, when it was first explained to me, was referred to as Rubyfied JavaScript. And I think that that is certainly true. If you write a lot of language applications in Ruby, and anybody here from Shopify? Yeah. Hey, what's up? Then CoffeeScript is incredibly approachable. Same thing for Python, actually. So as a gateway drug into actual JavaScript development, CoffeeScript has seen a lot of crossover. I think that's fantastic. TypeScript, of course, the Microsoft baby, which is now rising in the ranks, introduces strong typing and real object-oriented programming into JavaScript, which also made it feel like a much safer playground for a lot of developers. I think that I've been writing JavaScript for a while, but even when I started playing with TypeScript, it was significantly more comfortable, and I was able to write much more in my feelings structured applications by using something that I felt more comfortable with, coming from an object-oriented background. As far as Babel is concerned, this is really, I think, the truest, or at least the closest to pure JavaScript that we'll see as far as transpilation is concerned. This is what allows us to write like ES6 or ES 2015, however you want to refer to it. I must confess I forget what the official nomenclature is sometimes, and have that run ubiquitously across the internet. At the end of the day, I don't think we can deny the fact that JavaScript is the lingua franca of the modern web. However, by using that term, we are also accepting the premise that that means that it is something that we adopt and we shift into, that it is not necessarily our native home, right? Which can be whatever language we're coming from. Where are we now? There are hundreds of transpilers, hundreds of them. If you go to the CoffeeScript GitHub repo, there is a wiki page that has a list of everything that compiles currently to JavaScript, and it was last updated like a week ago, I think. The list is extensive, exhaustive, and we're not going to talk about that today. We're just going to touch on some of the highlights, because what I want to talk about, what I really want to focus on today, is this concept of attracting developers and engineers from other areas of the overall industry into JavaScript development. And so if we look at each of the languages that I've listed here, they attract a different group, or can. Yes, they also enable different features and functionality that you won't find in native JavaScript, so they protect those sides. But that's not really, in my opinion, the most attractive aspect of them, nor is it the ultimate goal. If you wanted to, enforce typing in JavaScript, you could do that in a number of ways. But having TypeScript already there as an available set, and a pretty straightforward compilation process to convert that into raw JavaScript, also the ability to actually write pure JavaScript within your TypeScript files, and it not cause too many problems, depending on your linter, is a very positive and strong, it's a powerful thing. And I think that that is probably why it is now one of the top 20 languages itself. Full disclosure, I'm a huge TypeScript fan if you haven't figured that out. But another very interesting one that's kind of coming up the ranks very quickly is Kotlin, right? Kotlin is everybody here familiar with Kotlin? Show of hands. No? Yes? Cool. Awesome. If you aren't, feel free to come in and approach me afterwards. I'll be happy to talk to you more about it. But Kotlin is a Java-like language introduced by the same people who have created one of the more popular JavaScript IDEs. And it allows you to write, it's a very Java-like language, but it is now also one of the more popular languages for writing Android applications. And they've also introduced JavaScript targeting. So you can write in Kotlin and both have that point towards the Android code base, and then you can take that same code base or components of it and convert that directly to JavaScript, and it minifies it and takes care of that for you. So for your Java developers who don't really feel comfortable writing in JavaScript, it's a much easier transition over to something like Kotlin. It's a dipping your toe in the pool if you want. Considering how quickly JavaScript iterates and evolves, has everybody seen that article about what it's like to learn JavaScript in, I think at that time it was 2016. It was on Medium, and it was pretty scathing. And lots of apologies there were a lot of apologists for JavaScript at that point in time. But regardless of the veracity of that post, the sentiment can't be argued with. JavaScript can be a scary place to try to get into. What exactly are you supposed to do? How are you supposed to get there? Which of these 3 frameworks should you pick? Which library should you use? Do I use an NPM or Yarn? Am I gulping, grunting, using pure NPM scripts? I mean, I don't even want to write JavaScript after trying to explain that, and I love JavaScript. So the ability to have something like Kotlin, where you can purely write an application that feels a lot like something that you've written for a decade or more, and then have that target JavaScript is very attractive. For our functional fans, we've got things like Elm or ClojureScript. I haven't written Lisp since I thought Emacs was cool, so something like ClojureScript can be really interesting. For our C fans, we've got things like Nscripted, which we'll talk about a little bit more later, and Google's Dart project. They're still a thing. As far as PHP and some other languages, yes, they're not necessarily as popular or I would say pure transpilation, but these cross-platform, almost like Rosetta Stones, are available. Hax is a good example. Has anybody here played with Hax? Yeah? All right. So essentially, you can convert from languages into Hax and then Hax into other languages. It's pretty cool. So I think the largest takeaway I would like you to get from this conversation is that the more ways there are to write JavaScript, the more people will write JavaScript. And the more people that write JavaScript, the better JavaScript gets. We want as many people in our pool as possible, because the more people in our pool, the more things end up getting written in this language, and the more innovation we can get. This is my fundamental premise, and the one thing I'd ask you to take away. Now, where are we going? The future of transpilation. I was initially going to talk here about WebAssembly. And WebAssembly is very, very cool. It's now shipped in all 4 of the top browsers. 1.0 has been stamped. But WebAssembly isn't JavaScript, right? Yes, they have similar pedigrees, I would say, and there's a lot of the same DNA, and they're trying to solve similar problems. But what I want to talk about today is truly the fact that JavaScript is right now. WebAssembly may come to fruition. It may see the adoption it needs to really take over as that common language. But at the same time, while JavaScript isn't an edit and refresh language anymore, not really. There are multiple steps. We do, pre, post, and peri compilation. Ultimately, it is a much more versatile and rapid language than having to compile things down to bytecode, web or not, every time. And I think that that is one of the true powers of JavaScript. And I would hate to see that go away. So, based on what we were talking about earlier, and the fact that we really want to expand this pool, and the ability for transpilers to allow us to write how we think, and then deploy the way we have to. Code how you think, deploy how you must. That's how I'd like you to think about transpilers. And if you haven't played with one yet, I'd encourage it, even if it's just to change the way you think for a little bit, come at it from a slightly different viewpoint. And if there's a language you've been curious about exploring, but weren't sure about the applicability, there's probably a way to ultimately take what you've written and have it back in the JavaScript that you know and love. Thank you. Any questions before I get out of here? Yeah. What are my thoughts on Flow? So I like Flow from the standpoint of taking, opening up the ability to write applications to groups that may not necessarily have felt comfortable writing those applications before. One of the companies I used to work at had one of their core values as seek diverse perspectives. And I think that, again, that helps spark and nurture innovation. So from that standpoint, I'm a huge fan of Flow. I personally find it difficult to write in, but I think that's just because my perspective is a little different. Philosophically, I'm all in favor. Does that answer your question?
Yeah.
Cool. Any other questions? OK. Oh, yes. I don't know how I keep missing people. Oh, my gosh. Hi.
Can you tell us more about WebAssembly?
More about WebAssembly. Sure. So WebAssembly, the goal of this is to create an assembly language for the web. Essentially compiled down to bytecode, supposed to be faster than JavaScript, and supported by all browsers. Also, you could write in any language and have it compile down to WebAssembly, or significantly more languages. Similar to the approach that transpilers take, but instead of having a scripted language and ultimately human readable at the end code, it would be pure assembly. OK, I'm really going to look hard this time. Any other questions? No. OK, thank you very much.